I'm just going to say it. Templates from sites like Slides to Go, Slides Mania, and Slides Carnival are visually stunning, and you should never use them to teach. Don't get me wrong, I love great design and I love these websites, but almost every pre-made template out there is built for corporate graphic appeal, and it's not built for human cognitive architecture. They're packed with decorative shapes, busy background patterns, and extra text boxes that actively force your students' brains into cognitive overload. There's actual peer-reviewed science on this. Decades of research by an educational psychologist called Richard Meyer proves that these aesthetic extras like decorative fonts, like busy backgrounds and busy layouts, will drain working memory and make it harder to retain core concepts. In this video, we're looking at 6 multimedia learning principles that every educator needs to know to protect working memory. We'll break down the worst hidden slide traps and make sure you stick around to the end, because I'm going to be giving you a checklist that's going to help you fix all of your slide decks from this point forward. Now, before we talk about these 6 multimedia learning principles, the first thing we want to do is talk a little bit about working memory and working memory capacity. So really understanding the why behind these principles before we get into the actual design tips. So our goal as educators is to manage working memory capacity. And why is this important? Well, cognitive science shows that working memory can only hold about 3 to 5 chunks of information in our brains at any one time, and it's going to vanish if it isn't actively processed. So we have information coming in, going into our working memory that gets then encoded into our long-term memory, and that's kind of the goal of learning. So when we overload our working memory with things like those decorative fonts and those busy backgrounds, we're taking up some of the slots within our working memory, so that we're now causing a cognitive overload for our students, and they can't then just focus on the information and process that information because they're too busy with the other stuff. So we're taking away from the important learning. So really understanding working memory is really the single most important key thing in slide design. And every choice that we make should be about protecting that limited working memory for our students. The other thing that's really important to know is a little bit about the dual coding theory. So what this says is that working memory is not a single processor, but it actually consists of 2 separate channels that are complementary to each other. And so each channel can hold those 3 to 5 chunks of information. The first channel is the verbal processing channel. So this is what we hear. And the second channel is our nonverbal processing, or what we see. So having these 2 channels come together can help process both spoken as well as visual image simultaneously without inducing a double penalty to your working memory. So that means you can have 3 to 5 chunks of information in both channels, which can be really, really helpful. If, for example, you show a picture of a tree and then you also have the word tree with it, it can help reduce the strain on that working memory and can help build some of those connections between the 2 different things. It's going to overall enhance the long-term memory for that particular thing. Okay, so now that we have those 2 concepts, let's jump into some of our design principles. The first principle is, it's called the multimedia principle. I mean, it doesn't really matter if we talk about what it's called, but if we're looking at this design of this slide here, this is kind of a really bad example. Because we have lots of words on these slides here. Words are, without any kind of visuals, are going to force us to mentally construct images that are based on the inferences we draw from the words themselves. And so that can be really demanding for our working memory. So instead, we want to use relevant words along with graphics together rather than just words alone to really help create those connections. So this is a slightly better design here. The simple fix is to use both words and visuals instead of just words. So for conveying this particular concept of photosynthesis, we have a picture of photosynthesis shown with the plant and the sunlight and the oxygen and so on. And we also have the words on the slide as well. So a simple fix would be to use both words and visuals instead of just words. Now, this is still not a great example, and that's because this is basically our single most violated rule in education. And I see this so much in so many classrooms. And that is when a slide displays full sentences while you talk. And the problem with this is that students will experience split attention. What's happening is the brain can't read on-screen text and process spoken language at the same time. That visual channel is getting absolutely crushed. This is called the redundancy principle. So while it's great to have these full sentences on your slides in terms of knowing what you want to say when you're teaching, it is not the best for learning. And instead, what we should do is if you're talking, the slide should contain only key terms, labels, or diagrams, and you have to move those full sentences into your spoken delivery or your lecture notes. And that can be really hard. I understand that can be really hard, especially if you're teaching something that you're not super comfortable with. This is where you want to go through, practice. Use your speaker notes in your slides tools if you aren't sure what to say. You just want to get the words off of the slides, and you could have them in speaker notes. You could have, say, for example, the speaker notes on your iPad in front of you so it doesn't look too terrible. And maybe use, instead of full sentences in your speaker notes, you could have just kind of key bullet points to help you remember what you need to say about your particular slide. Okay, so this is much better. We've got now just keywords on here as well as a diagram representing our photosynthesis process. Our next one is actually called the Spatial Contiguity principle. This is a bad example. Basically, it's any diagram you have, you want to do direct labeling versus including a legend. So this would be a really bad example where you have, for example, okay, number 1 is here. So it's up at the top of your screen there. And then you have to go find number 1 in the legend on the side. And then you go number 2. Okay, what's number 2? It's the right ventricle. And then, okay, where's 3? 3's there, the left atrium. So that's really hard for students to do. Having those legends and numbered keys are going to force students to dart their eyes back and forth across the screen and try and match the numbers with the labels themselves. So this kind of scanning really drains that precious working memory bandwidth before any actual learning can happen. So to improve this, we want to directly label our diagrams. So this is a better example where we're placing the text labels directly on or immediately adjacent to those relevant parts of the graphic with those short pointer lines. So it's already far easier to find, say, the left atrium or the right atrium and so on and so forth. So any kind of labeling, you always want direct labels versus doing a legend with the numbers on the side. Now this leads us into our next principle. It's called the signaling principle. The problem with this diagram, especially if you're going to talk about it in context of, say, you want to talk about the blood flow through the heart. Your students are not going to know where to look on the slide as you're talking about it. So if I say that we start in the superior and inferior vena cava, and then it goes into the right atrium, gets pumped to the right ventricle, gets pumped back out of the pulmonary artery, you're probably already going like, okay, where am I looking and where are these things? So that's what's happening with your students. They don't know where to look on the slide. So if you're showing complex images like this, students are actually wasting a lot of that cognitive energy hunting for exactly what you are talking about. So if you wanted to talk about, say, for example, the blood flow through the heart, I don't know why I keep having such issues saying that. What you can do is you can use visual cues like bold accent colors, high contrast callouts, arrows, spotlights, boxes, whatever you need to help your students find the exact focal spot they need in any given moment. So if I was to again go through that blood flow, I would say maybe, okay, we're starting in superior and inferior vena cava. And so I've got those two structures highlighted in red. And then we're going to go and the blood's going to dump into the right atrium. And I've got that highlighted. And then the right ventricle. And then pumped out through the pulmonary artery, out to the lungs, and so on and so forth. So I'm not going to go through the whole thing, but you kind of get the idea that you want to highlight each structure as you're talking about it. So you can use boxes like this. You can use bold accent colors, whatever makes sense for you. Use the animation features in your slide software. If you need a tutorial on how to create those animations, let me know in the comments and I will do that for you. Our next principle is the coherence principle. Basically, it's the cut the fluff. While I love a good science meme, like I love them, there is a time and a place for them though. And on your slides and in your teaching is not the place for them, even though it pains me to say that because I love them so dearly. A good science meme just cracks me up. Decorative stock photos, fun clip art, thematic GIFs, memes might feel engaging, but cognitive science labels them as seductive details. Basically, what they do is they draw visual processing power away from the core concept. So if I was teaching about Ohm's law here, you can see I've got lots of words, which goes back to our first principle. I've got the diagram with our equation here, and then I've got this really great meme about ohms. You can read it, you can laugh about it if you understand it, but the meme about ohms is really drawing away from the central core concept of what Ohm's law is here. So a better example would be to cut the fluff, get rid of the meme, and also get rid of the words, because that's, like I said, that's going back to the redundancy principle as well. You don't need the words because it's not really adding meaning here. So every single element on your slide needs to directly serve the learning objective. If an image doesn't actively help explain the schema, get rid of it, even though it looks lovely and it's so good. The last principle is the segmenting principle. So what this one says is that you don't want to put all the details up on the slide. So if you're going through a complex calculation, for example, you don't want to throw a complete finished 6-step diagram or dense multi-lens equation on the screen all at once, because that creates visual overwhelm. So we have this example here of a problem-solving process. If you are new to this, right, and looking at this, you'd be like, where do I focus my attention? So instead, the fix is to use progressive disclosure. So you can use simple appear animations or step-by-step slide builds so the information is revealed only as you address it. So for example, you could start with the example here of the example question. Then you could go through, okay, well, what information are we given? You could even, as you're coming up, like V equals question mark, you could highlight in the question where that part is within there. Or the I equals 3.2 amps, you could highlight in the question where that is. And that would give another visual indicator there. I have not done that in this example. I just wanted to keep it simple, but adding the highlights would even make this even better. So you would go through it step by step, and then you would go through, okay, here's the equation we're going to use. Here's us subbing in those values, and then here's our final answer. So walking it through step by step reduces that cognitive load on our working memory and makes for better learning for our students. Okay, so what have we learned? Well, here is your simple checklist to use going forward to fix any slide deck that you create going forward. First off, keywords. You want to use keywords on your slide along with oral explanations. So make sure you're using a mix of keywords and visuals as well to prevent visual and auditory conflict. The next is you want to label diagrams directly on the diagram itself, so avoid any legends because that's going to help eliminate scanning fatigue. You want to use bold callouts or highlights, and that's going to help direct visual attention to where you want it to go. You want clean white space and functional graphics only. Reduce that extraneous clutter. Get rid of the fun memes and fun visuals that are not adding to the explanation themselves. And then finally, you want to use animations to build complex line-by-line explanations, especially in problem solving, to manage that complex information. Now that you know what to do, you can take it a step further and build yourself a custom Google Slides template that you can use over and over again. If you want to see the one that I use, be sure to check out this video next.